Now, there are different types of languages. As mentioned a while ago, assembly language is actually considered as a low-level language. For high-level language, this includes the basic or the visual basic. We have that, the Fortran, the COBOL, the Pascal, the C, the C++, of course, C Sharp, and Java. So these high-level languages uses already what we call compiler. Compiler translate a program written in a high-level machine language. So in this case, when you say high-level, it's already like an English language. The program will already uses variables that can perform also arithmetic operations. We do not need already to use mnemonic keywords to store values, to load values, and multiply values. So let's say, for example, as the example earlier, we have wages is equals to rate times hours. For example, we use C++. Instead of using load rate, multiply hours, store wages, we use the same instructions as what we had in our equation, just that we change the period, or sometimes we use X for multiplication, so we use asterisk sign. Since asterisk sign is actually the keyword or the syntax for multiplying values in C++ and in other high-level languages. Now, this is actually an example already of processing a C++ program, or this is already what we call the syntax in C++ program. Okay, so later on, we're going to discuss and we're going to define this uh, program step by step. So for now, let's keep that. Okay, so now, we saw already an example of a program in C++. How are we going to execute a C++ program? So first, before we execute the C++ program, if we want to type the code or the keywords or the syntaxes, we need to use an editor. Okay, so an editor in C++ is actually to create a source program in C++. So that means whatever we type, whatever keywords we actually included in the editor is actually what we call the source program in C++. Of course, in programming, in C++ programming, we use also preprocessor directives. Preprocessor directives are this one. That includes the sharp sign, that includes syntax, and a header file or a library. Okay? So again, preprocessor directive begins with a sharp sign or a pound sign and are processed by the preprocessor. And other compilers use also object programs or OBJ. But in our case, since we're going to deal with dev C++, there's no more OBJ format, only .cpp and .exe. Okay. Now, we have also a linker and a loader. So when you say linker, linker is actually combines object program with other programs provided by the SDK to create executable code. So if we have already a linker, it will be actually generated to an exec file or .exe. So after the linker, of course, once we created the executable code, we need to also use a loader. A loader is loads executable programs into the main memory. So after we have the linker and the loader, we are already ready to execute the program, and this is the last step. Okay, so in summary of that, okay, so as mentioned a while ago, we're going to use C++ programs, particularly in our subject. And to do that, we need to have an editor. So we're going to use dev C++, and dev C++ already includes editor. So in an editor, we need to type the program, and the first part of the program of C++ is what we call the preprocessor. So again, preprocessors begins with a sharp sign. And in addition to that, it includes also the header files like IOStream. And then once the program has been typed on the editor, we can already compile it, and compiler will check on the syntax errors. So if there are syntax errors, so we need to debug, okay? So we need to debug it, okay, and go back to the editor to edit our code. So again, we use preprocessor if we miss something, and then again, the compiler will compile the code. If there are no syntax error, okay, then it will be proceeded in the linker to create an executable code as well as in the loader. And now, after that, if there are no syntax error, we already have an executable code, we can finally execute the program and get the input and then process it, and we can see the output of the program. So if you have any questions regarding this particular slide, you may actually do the consultation or during our lecture in chapter 2 by next meeting, Monday. You can actually ask questions before we start the discussion for chapter 2. Okay, so right after we discuss all about the different types of programming languages, so what should be the programming with the problem analysis, coding, execution cycle? So programming is a process of problem solving. So when you say problem solving, what are the techniques in the problem solving? First, of course, if you have the problem, you need to analyze first the problem. Okay? So when you analyze the problem, what is analyzing the problem? Okay, so you need to understand well step by step the problem, and you need to um, outline the problem requirements. Okay, so once you already have the requirements, you know already what must be the variables, or what are the variables, what must be the input, how are we going to process the output, and what must be the output. So you can already have the design steps or perform the algorithm to solve the problem first before you do it in C++ program. So when we say algorithm is actually a step-by-step problem-solving process. Solution achieved infinite amount of time. So when you say finite, okay, it's not infinite, it's finite. When you say finite, there must be a start, and there will be also, or there must be an end to your algorithm. Okay, so to do the problem analysis, coding, execution cycle, step 1 is we need to analyze the problem. So as mentioned a while ago, you need to outline the problem and also the requirements, and then you design the steps, perform algorithms such as flowchart or pseudocode. So most of the programmers uses pseudocode instead of flowchart. So when we differentiate pseudocode to flowchart, flowchart is basically the graphical or the pictorial representation of an algorithm. Uh, and pseudocode is actually, it's like an instructions already, like a different programming language. So after analyzing the problem, we can already implement the algorithm. Okay. So how we are going to implement the algorithm? Of course, we're going to implement it in code. So in our case, we're going to use C++. And then we can actually already verify the algorithm if it's working by what? Again, by uh, testing it, by compiling it. If there are no syntax errors, we can already perform inputs, and then we can identify whether our inputs has a logical errors. So although it's syntactically correct, okay, we cannot assure that it's also logically incorrect, or logically correct rather. Okay. In step 3, maintenance, we can use and modify the program. Okay, we can edit the program, or we can actually edit the codes if the problem domain changes.